Today, we're going to take a behind-the-scenes look at the Large Lakes Observatory. Before we begin, I'd like to highlight some of our past programs. We've explored places like the Minnesota Landscape Arboretum, Amsoil Arena, Superior Hiking Trail, the proposed UMD Sales Center, the UMD Chocolate Lab, Romano Gym, and many more places. You can access all of these events on demand at our website, d.umn.edu/alumni. Today's webinar is being recorded and will be uploaded to our Alumni Relations website. You will receive an email with the link once it is ready. Finally, we will have time at the end of the presentation to answer live questions. To submit a question, use the Q&A button on the bottom of your screen. So now it is my pleasure to introduce Bob Sterner, who is our guest speaker today. Bob is the director of the Large Lakes Observatory and professor in the Department of Biology at UMD. His expertise lies in the field of lake research, with a special focus on the Great Lakes since 1996. With a passion for teaching, Bob has dedicated his career to educating others about our environment and the importance of preserving our precious resources. We are thrilled to have him here today to share his knowledge and insights with us. Without further ado, I would like to welcome and hand it over to Bob.
Thanks, Molly. Great to be here and really appreciate everyone's interest in this wonderful place that's called the Large Lakes Observatory. We're going to start with a short video clip we recorded earlier today, just outside of the research lab building where we work.
Hi, welcome to Bulldogs Behind the Scenes. Bob Sterner here. And behind me is the research lab building, which is the campus home of the Large Lakes Observatory. Research lab building is almost 100 years old, and it began its life as a lab school where students at Duluth State Teachers College came to learn to be teachers. Since that long history, LLO took it over. LLO's been here almost since its very beginning, and we've converted this old lab school, this elementary school, which used to serve the neighborhood children, we've converted into a place for modern science, and we'll be telling you all about the kinds of things we do throughout this program. Hi, welcome to Bulldogs Behind the Scenes.
Yeah, so that's where we work in our laboratories here on the UMD campus. This image I really love because of its mysterious feel. This is the bow of our research vessel, the Blue Heron, which you'll be seeing a lot of in this presentation. And to me, this image captures the kind of mysterious nature of the lakes that we work on. Our mission at the Large Lakes Observatory is to perform innovative, cross-disciplinary research, education, and outreach on Earth's large lakes for the benefit of society and the sustainability of fresh waters. No other group, to my knowledge, has exactly that same mission, which is to do science on the large lakes of Earth. There are plenty of lake institutes around the world, but none, as far as I know, which take on this incredible challenge of studying the largest lakes over the entire planet. Large Lakes Observatory is part of the Swenson College of Science and Engineering at UMD. We are a dozen faculty coming from several departments, including physics, chemistry, biology, and geology. And at any one time, there's usually around 50 students, staff, and faculty who are actively engaged in this mission. I'd like to say that our science helps write the user's manual for these valuable ecosystems. To understand why LLO exists, let's talk for a minute about water at the planetary scale. Sometimes our home planet Earth is referred to as the water planet because more than 70% of its surface is covered by water. You may be familiar with Carl Sagan's famous description of Earth as a pale blue dot, which conjures up an image of a very watery place. But what if we think not about the percent of Earth's surface covered by water, but instead about the volume of that water? When we take all of Earth's water, every drop that's in the oceans, that's in the ground, that's frozen in polar ice caps, and we convert that into a spherical volume, we see this largest blue sphere actually representing all of that water on Earth. The image of Earth as a pale blue dot certainly changes when we think about volume, not about surface area. But we can go further. Most water on the Earth is in the oceans or in ice. So when we look at the totality of fresh liquid water, the sphere gets even smaller. But a lot of this fresh liquid water is deep in the ground. So when we look at just the most accessible portion, the fresh liquid surface water, the volume becomes so small it's very difficult to see on this image. This smallest drop represents most of the water that all of humanity, all 7.9 billion people, rely upon for food, for fiber, for drinking, to carry our wastes, and to allow our supporting ecosystems to exist. From this perspective, we could say that Earth isn't the water planet at all. In fact, Earth could be called the desert planet. Taking this one step further, let's look at that tiniest drop and ask where the liquid surface fresh water that humanity needs is actually located. Turns out almost all of the liquid water in that tiny drop in the image on the left is found in a small number of lakes. The most voluminous lake on Earth is Lake Baikal in Siberia, here in blue. Next is Lake Tanganyika in orange, and third comes Lake Superior in our own backyard here in Duluth. Most Duluthians know that Lake Superior is Earth's largest lake by area, but it's also one of Earth's largest by volume. It may come as a surprise to you to learn that only 5 lakes here, 1, 2, 3, 4, 5, contain more than half of Earth's liquid surface fresh water. 5 lakes. Some people call water the most precious substance on Earth, and I invite you to ponder on what it means that that most precious substance is located in such a few places around the world. So I want to tell you about LLO's research. LLO's research is very diverse, exploring a wide range of fundamental topics, many of which have direct practical implications. Let me now tell you about a few lines of research that LLO has pursued and is pursuing. I only have time to tell you about a few of them, but I hope these will give you a good taste of the work that we do. One topic that's garnered a lot of attention recently is the widespread occurrence of plastics in the environment. Many scientists around the world are working to understand where these plastics come from and what impact they may have. Large lakes may be important collectors of microplastics because large lakes have long residence times. Doctors Liz Miner and Katie Schreiner at LLO, along with some of their colleagues in and out of UMD, are deeply engaged in studies of environmental microplastics. Their organic biogeochemistry knowledge enables them to do state-of-the-art chemical characterization of microplastics. This is necessary because of the diverse nature of microplastics in the environment, which can come from many sources. Knowing more about what types of plastics are found in our surface waters helps us understand where they come from and what effects they may have. One technique used in this research is referred to as micro-FTIR. In this video, Eric Henderson of Dr. Miner's lab tells us about a brand new piece of instrumentation in the lab.
So this is our new micro-array FTIR from Lumos. It's a new model that they have, and it's equipped with a focal plane array detector for FTIR. So what this allows us to do is to take a bunch of JPEG images of a filter that's been concentrated all the microplastics from a given sample or matrix, and it allows it to autonomously scan that filter for microplastic using infrared spectroscopy to positively detect microplastic particles and distinguish them from natural materials that otherwise may be left over.
As you can see, some very advanced chemical techniques are needed to understand what plastics are found in the large lakes of Earth. This work begins with sample collection, some of which we'll see in a later video. And then it goes through a processing step and ends up with the kinds of analyses that Eric just told us about. Surveys of Lake Superior done by LLO have found similar levels of microplastics as are found in the world's oceans. Most of the microplastics in Lake Superior are small, and they're mainly polypropylene and polyethylene. Work like this brings sophisticated tools to bear to address questions of great social interest. So now we go from the very small to the very large. LLO research faculty member, Dr. Sam Kelly, is part of a large international team based mainly out of the US and France, which is working to make the first global survey of Earth's surface water. The SWOT, or Surface Water and Ocean Topography Mission, came alive in December 22 of last year when a satellite equipped with radar interferometry was sent into orbit. The satellite detects small differences in the water surface elevation. The freshwater portion of this project seeks to provide a comprehensive view of Earth's freshwater bodies and allow scientists to determine changing volumes of water across the globe at unprecedented resolution. Dr. Kelly's role will be to use this new technology to further our understanding of the hydrodynamics of large lakes. In large lakes, as well as the oceans, this satellite will enable measuring currents at a finer scale than ever before, because currents have an expression in the surface elevation of large lakes. A better, more accurate description of hydrodynamics will enable advances in chemical, physical, biological, and geological analogy. The next research story I want to tell you about has to do with a topic near and dear to our hearts in Duluth. That is winter. A cold winter is a big part of the year in these parts. Winter's been a time when scientists tend to stay home, teach classes, and analyze their samples. But the lakes are still out there in the winter, and it hardly makes sense to only watch part of a year-long movie, or we might miss out on big parts of the plot. So in recent years, opening the black box of winter has been a big scientific focus here at LLO and elsewhere. Winter is a difficult time to study nature when it comes to large lakes. It also means a high degree of danger. During the winter of 2021-22, LLO scientist Dr. Teddy Ozerski led an effort that included 19 organizations in the US and Canada, which together sampled 50 sites throughout all 5 Great Lakes, providing a first ever snapshot of what is happening at this coldest time of the year across the Great Lakes. They called this effort the Winter Grab. Now I have a short video put together by Minnesota Public Radio News that I'm going to play for you, and it has a little bit of background audio, so you'll want to listen.
Hamstring cramp. Uh-oh. There's not that many.
That's not diverse.
That's the joy of cold water.
Yeah, but that time was clear
just
ice.
Like 10 for all of them. It was 10 for all of them. It's like just shy and just over. Depth, should I just put 30?
30 meters. Yeah, definitely.
Most scientists are very busy during the summer, but as we saw, some of us are also busy in the winter. Winter is very different in some respects because ice covers the lake and alters the conditions below it. Climate change is affecting the amount of ice on Lake Superior and other big lakes, and it's especially a concern in the Great Lakes, as we'll see a little better now. It may come as a surprise to learn that this great mass of cold, clear water outside our windows in Duluth is one of the fastest warming lakes on Earth. LLO faculty members Dr. Jay Austin and Dr. Steve Coleman published 2 papers back in 2007 and 8 that turned a lot of heads. Knowledge of climate change was less then than it is now. And in those early papers, they showed for the first time how rapid the rates of increase of Lake Superior summer surface temperatures were. The very memorable finding was that Lake Superior was warming faster than the air was. There's some very interesting physics behind this, but we'll have to leave that for another time. More recently, Dr. Austin joined forces with a large number of other scientists to develop a global understanding of how lake water temperatures were warming across the Earth. Their analysis showed that warming was widespread, with warming lakes located across the Earth. The little box and whisker graph here is an inset, shows how two locations in Lake Superior, the eastern and central buoys, have been warming at above 1 degree Celsius per decade, which is in the upper range of rates of warming of all lakes. Lake Superior's summer water temperatures are warming and warming fast, and they're warming faster than most lakes on Earth. Realizing how climate sensitive Lake Superior is has generated a lot of additional questions, and it's increasingly a part of management efforts. This is a great example about how the basic science that we do at LLO often has direct practical management implications. Tied to that is a research story that actually unfolds in my lab as well as Dr. Cody Sheik's lab here at LLO. And it concerns a surprising and more recent environmental trend. For about the past decade, portions of the Lake Superior near shore have turned from their usual clear condition to one more resembling melted green crayon. This discoloration arises because of dense populations of blue-green algae or cyanobacteria. Work in mine and Dr. Sheik's lab at LLO have concentrated on building the basic knowledge needed for us to understand why the lake has started doing this. These algal blooms now mean that all 5 Laurentian Great Lakes are subject to summer cyanobacterial blooms. Some of the blooms elsewhere in the Great Lakes are larger and last longer and result from other algal species than the ones we see in Lake Superior. But clearly there's some differences from lake to lake, so knowledge from one location may not easily transfer to other locations. And the other Great Lakes, nutrient sources from agriculture are paramount in fueling blooms. In Lake Superior, we think it's those warming conditions we just talked about, combining with heavy sediment load from major storms that which combine to create these new summer cyanobacterial blooms on the lake. A small part of the lake is actually affected by these blooms, but as you can see here, it's the part of the lake which has a lot of human contact. Let's hear from a couple of LLO graduate students whose work is helping us to build the knowledge base necessary to understand these blooms so that wise management can follow.
Hi, my name is Rianne. I work in the Sterner Lab here at LLO.
And my name is Rob. I also work in the Sterner Lab.
And together we are tackling the big question of why are we experiencing harmful algal blooms in Lake Superior. So I'm working on the nutrient dynamic side of things. So how does phosphorus and nitrogen impact these harmful algal bloom formations?
And I'm doing similar work as Rianne, except I'm looking at the rarer nutrients, looking at some metals such as iron and molybdenum that are really important for these algae species out in the lake, but are pretty understudied.
So our take homes from this work so far is that the drivers of Lake Superior blooms are different from elsewhere in the Great Lakes, and that they're related mostly to both climate warming and intensified storms. LLO, as I mentioned early on, has a mission to study the large lakes of Earth, and we truly have a global reach. LLO scientists have examined the food web of Lake Baikal in Siberia. Many studies have been performed on the history and current state of multiple lakes in East Africa. LLO scientists have worked in the Philippines and in Central Asia. Some of our work has occurred in Arctic Alaska, and recent work has looked at paleoclimate studies being performed in both Central and South America. One of the things that sets LLO apart and makes us recognizable in the region is our research vessel, the Blue Heron. The Blue Heron was launched in 1985 as a fishing trawler on the Northeast Atlantic coast. Its early life was spent pulling cod from the ocean. After the cod fisheries collapsed, though, the vessel was purchased by the University of Minnesota in 1997 and converted to scientific use. And that way, it went from contributing to the unsustainable exploitation of a marine resource to helping us build foundational knowledge for the sustainable use of the Great Lakes in the future. Here we see the Blue Heron departing on one of its scientific missions. The Blue Heron is truly a unique scientific resource. It has served the scientific community for over a quarter century. It's the only Great Lakes vessel in the U.S. academic research fleet, which means it's managed similarly to some of the largest seagoing oceanographic research vessels in the world. An awful lot of science has taken place on the Blue Heron's decks. It served as a platform for more than $30 million in scientific funding. And importantly, it's also a valuable educational tool. More than 3,000 undergraduates have sailed on the Blue Heron as part of their curriculum at UMD. It also helps us communicate the importance of science to the wider public. More than 8,000 members of the public have been on board during one of our outreach days called Science on Deck. The Blue Heron is still very seaworthy, but we hope to replace it with a newer vessel in the near future. Let's take the Blue Heron out now for about 2.5 minutes and listen to some of the scientists on board.
I love being on the water. A bad day on the water is better than a good day in the office. I get to be a professor on campus and I get to teach classes and work with students and other faculty, but this right here is my laboratory.
Out on the lake is definitely the best part of our job. Most students and myself, we like being on the boat. It's a great environment. It's beautiful. It makes us appreciate and have a respect for what we're doing.
One of the things that my lab does as part of something called the Great Lakes Observing System is putting meteorology buoys out in the western part of Lake Superior. They measure a whole host of different meteorological parameters, things like wind speed, wind direction, air temperature, wave height and wave direction.
Today we're going to be doing a bunch of fishing for microplastics. Microplastics are teeny tiny pieces of plastic. Some of them started out as macroplastics that you might see like plastic bags or PVC pipe, and they get beaten up in the environment and made small. And others are actually natively small, so bits and pieces off your laundry that go out your dryer vent become microplastics. This lake is one of the most pristine in the world. It's definitely the most pristine of the Laurentian Great Lakes, and so there's a great pride to keep it clean. And so understanding how many microplastics are there will help us to know what we need to do to try and keep them out, and what's likely to happen in terms of the ecosystem with the ones that are there.
This boat is easily the largest academic boat on the Great Lakes. I've worked on a lot of boats. When I was an oceanographer, I worked on boats on both the west and east coast, and the Blue Heron crew is friendly and collegial, but also extremely flexible. They enjoy a challenge. These systems are, considering the impact they have, both sort of ecologically, but also sort of culturally or even commercially, it's amazing how little we know about them. And so this is a worthwhile investment.
That is cold. Yeah. Cold water. Yeah.
Our mission is basic science, and most of our funding comes from the National Science Foundation in Washington. But I like to say that when you're working on research topics in water, you're never very far away from things that people really care deeply about. And so the work that we do, though fundamental in its nature, attracts a lot of attention. So we're going to look now and see some of the news stories which have appeared just in the past couple of years that have to do with the work that we do at Large Lakes Observatory. You can see the diversity of topics and the numerous news outlets which have paid attention to the work that we do. But while I have you today, I want to talk about some of the significant challenges that LLO faces. We face really significant infrastructure challenges. Many of these derive from our outdated campus home, which I spoke to you in front of at the beginning of this program. Though a lot of clever things have been done to house modern science within research lab buildings' walls, the building falls short in numerous ways. Upkeep is very expensive. There is no or little climate control, meaning some of our work has to be paused during the hottest times of the year when instruments can't cope with the heat. RLB's windows are ancient. The pedestrian bridge leading to the front door is literally falling down. In short, research lab building is falling apart, and it's not suitable for the kinds of work we do. It would be very cost prohibitive to bring it to modern standards. The status quo just cannot go on. Another issue is that our research vessel lacks a permanent home. We've been able to lease space in the harbor, but doing so puts us at risk because we don't control that space. Furthermore, we can't create the kind of shore support or infrastructure that's needed to support the kinds of work we do with large equipment on the Blue Heron. Our scientists have actually been known to work on their equipment outside on the dock, under the stars, and subject to the weather. This is hardly an ideal environment for sensitive electronics. These problems can't easily be fixed, but I'm very excited to say that there are discussions ongoing that could make a huge difference to the future of LLO and in fact to UMD. Here's an image of the Duluth Superior Harbor. I'm speaking to you today from the UMD campus, which is right here. And two locations where we've docked the Blue Heron are here and here. We're presently using Montreal Pier in Wisconsin, the use for which we're very grateful to our colleagues at the University of Wisconsin-Superior. This last location on the map is the last undeveloped parcel of real estate on the water in the lower harbor. It's referred to as Lot D, and it's owned by the city of Duluth. Lot D occupies space that represents the transition between tourist Duluth and industrial Duluth. Duluth has begun work through a private developer, first to make the property inhabitable in the first place because it needs work, and second to transition into developing the parcel, which ultimately could include housing, support for tourism, hospitality, and other things. We would love it if Large Lakes Observatory and UMD were part of this project, and discussions are ongoing. Here's a closer view of Lot D, and this location offers many exciting possibilities. The site potentially could provide a place for LLO to keep its ship in a location easily accessible from our laboratories and with proper shore-based facilities to go with it. I also want to note it would give UMD a highly visible harbor presence, putting it in front of the many tourists, for example, who visit Duluth on summers. It could, in this way, it could put UMD's water programs, not just LLOs, but all of UMD's, in front of a large and educated public. This is truly a once-in-a-lifetime opportunity. So the vision we have is to create a new UMD Discovery and Outreach Center on the harbor, home for our research vessels, and with accompanying public spaces to put our work even more in front of the eyes of the public. Doing this would position one of UMD's premier research and graduate education programs, which actually is an economic engine in Duluth for the future. So in closing, I hope that these glimpses behind the scenes at LLO have given you a better understanding of our many activities in researching the incredibly valuable large lakes of Earth and unlocking some of their mysteries. While preparing the scientists and citizens of tomorrow with opportunities to learn and to grow, and through events such as the one we're having right here today, to communicate some of the passion and excitement we feel when we're writing the user's manual for the large lakes of Earth. So for more information and to keep you abreast of LLO's activities, please join us at the next Science on Deck, which will be at the end of September at Pier B in Duluth. Come on down to that location and climb aboard, see the boat in person, and talk to scientists, staff, and faculty. We are launching a new newsletter, which will be coming soon. And so we hope many of you will be interested in receiving news about the Large Lakes Observatory several times a year through this newsletter we're calling the Large Lakes Observer. It's yet to come, but it won't be long. You can find us on Facebook, or you could follow the UMD buoys on Twitter and receive from them a tweet about every 20 minutes that tells you about the lake conditions. That's a lot of fun. That's it for me. I hope you enjoyed this presentation, and I understand from Molly that we'll be turning to questions at this point. Thanks for your attention.
Thank you so much, Bob, for sharing about this important resource. Yes, we're going to transition to our Q&A now. So we'll flip our cameras on and we will get started here. Perfect. So as a reminder, if you do have questions that you would like to ask now, feel free to use the Q&A button on the bottom of the screen. There were, however, a number of questions submitted through the registration, so we will try to answer as many of those as time permits. So there was a couple questions, Bob, related to kind of the economic impacts of LLO. So can you talk a little bit about how it does impact our regional economy?
No, I'm really happy for that question because that was a little piece I left out in the interest of time. So a couple of facts and figures about that. The sort of payroll of LLO, if you will, the salaries that our students, staff, and faculty receive through state funding, through tuition, and through federal grants amounts to about $1.5 million per year. Similarly, the total research expenditure at LLO currently is about $1.5 million per year and growing. And so by those measures, we provide about $1.5 million to the local Duluth economy. A significant amount of that is federal research money, which comes here because we're here and because the Blue Heron is here. There are other spin-offs that will be much more difficult to measure. The workforce training that we do is vital to the region. There are lots of other things, but those numbers are the most readily kind of available ones.
So similar, on that vein, does LLO work with any of the shipping agencies? And if so, how?
Yeah, great question. Also, the answer is yes. We probably could do more. We are in pretty frequent contact with the Duluth Seaway Port Authority, and they have lent their support for the idea of LLO being at Lot D, for example. The work we do on climate change affects water level. Water level is very important to the shipping industry. And so our science is kind of lying under in a fundamental way the kinds of activities that the shipping industry carries on. Something we probably could explore more, and I'd be interested in talking to anyone about this who might be interested in pursuing this, but using ships, as in science we call them ships of opportunity. It is the case that some commercial vessels have been equipped with scientific instrumentation. We have a lot of that instrumentation on the Blue Heron, but the possibilities there to do more with our regional partners who are going back and forth across the lake all the time.
So we have a couple questions related to kind of the climate sensitive aspects of the lake. And so the first question is, wondering to what extent does LLO and the research findings, how are they shared with policymakers?
Yeah, as much as we can and in every way we can think of. So by nature of the kind of work we do, we're not just, and I don't want to, diss any of my colleagues in other fields, but we're not just writing journal articles to one another. We are often in person or in other ways in front of managers. I'm giving a talk to the folks at Bar Engineering sometime soon, in a week or two. I forgot exactly when. So we have direct contact with agencies, with the private sector, really all the time. But on the other hand, our job isn't permitting, regulatory, that's their job to do. We provide information for them so that they can do a better job of what they do.
We just had a question submitted, kind of a two-part question. So as a global research lab, who would you identify among LLO's peers?
Oh, that's a great question. So it kind of depends on what aspect of LLO you want to talk about. So within the Great Lakes community, we are not the largest, but one of the largest groups of water scientists working on the Big Lakes. The largest single lab is a NOAA facility that's located in Ann Arbor with a bunch of federal scientists. We interact with them all the time. On the academic side, we are the largest, I think it's fair to say, group of academic researchers with a specific focus on Great Lakes or Large Lakes. So at LLO, because of this Large Lakes business, we have to operate scientifically, both with sort of 1 foot in limnology, or the study of inland waters, and the other foot in oceanography, because we typically use oceanographic scale studies. And so that's very interesting for us, because we have to be able to communicate to two largely separate communities of scholars. In the freshwater side, there are a small handful of institutions that are sort of the movers and shakers in freshwater. I think it's fair to say LLO's in that group of, a half dozen or so of the most highly regarded water units in the country. So again, it just sort of depends on what yardstick you want to use. I don't want to mention too many names, because if I do, I might leave some out, and that's not great.
So we had a number of questions related to kind of the impacts on the ecosystems. Very specific question, wondering about how the asbestos from the taconite processing affects the Great Lakes.
Oh yeah, that's a issue that goes back even before my time. I've been working on the Great Lakes for 20 years. That issue predates me. I am not really well equipped to speak to that. It's not an issue that is discussed very much anymore. And so I hesitate saying too much that's very specific about it. I just happen to have a book on my desk. For anyone interested in that topic, Dan Egan's book, The Death and Life of the Great Lakes, has a chapter about that reserve mining case that's really, really awesome. I learned a lot by reading it. It's more historical than talking about present day stuff. So I'm kind of deflecting a question, honestly. I'm not aware of any particular pressing environmental concerns that flow directly from the asbestos case. It was a big deal in its time.
A number of questions about impacts on fish, quality and types. The first question, there are two separate ones. This first one is wondering about the current status of sea lampreys and how that might affect the fish population.
Yeah, I can speak to that at a kind of superficial level. I'm not a fisheries person, but sea lamprey entered the Great Lakes in the late 50s when the canals were built, and along with fishing pressure, really hammered the lake trout and the piscivore, the fish-eating fish populations in the Great Lakes. They're still present. They still cause mortality to lake trout, and there would be many more of them if it weren't for an ongoing and multi-million-dollar annual expenditure to control those sea lamprey. They're controlled by putting particular lampricides, chemicals that is, to the best of anyone's knowledge, are benign to other organisms, but which kill lamprey. Those lampricides are applied in the streams where the sea lamprey breed. And if it weren't for that, there would be many, many more sea lamprey and many fewer lake trout in the Great Lakes. As an aside, I like to think about it often when I have a chance like now to mention that Lake Superior currently has a sustaining top predator, which is lake trout, which is the same top predator which existed upon European contact with the region. To some extent, it's fair to say, it's not exactly true, but it's fair to say that the food web of Lake Superior is largely intact, in spite of the fact that it's sitting here in the middle of North America. I find that just simultaneously sort of amazing to think about, but also incredibly gratifying to think that, you know, we have this place that looks an awful lot like it did 200 years ago, right outside our windows. It's a valuable thing.
So how would you say the mortality of the fish is changing with the warming temperatures of the lake?
I've been talking with some colleagues about that who know much more about that than I do. One recent conversation I had with one of the managers suggested that some of the least desirable fish might benefit the most from warming waters. And so that's a hypothesis, I would say, at this stage. That's not proven, but there's reason to think it's true. And so that's a place where the basic research on climate change immediately touches upon topics of great practical relevance.
And we have a couple questions about the proposed new facility. So you touched on it a little bit, but what does that timeline look like and how might it be funded?
Yeah, I could get fired if I say too much about that right now. So I won't say too much, but progress is being made. Timeline is still unclear. Would, in the best of all circumstances, would unfold over the next few years. A lot of things have to go right for this to happen, but we are where we need to be in order for this to be successful. So one of the hurdles is, I mentioned, this property needs work. It needs substantial public investment in order to even bring it to a developable, if that's a word, state. And so the university doesn't own this land, City of Duluth does. City of Duluth can't afford it, you know, on their own. So we're going to need public support to see that property renovated, seawalls built, land cap put in, some old cement removed. That will take money, it will take time. The university doesn't do anything like build buildings quickly, but I'm really gratified at the level of interest and support that we're seeing internally at the university, and all the partners we've been working with outside the university have been very excited about us being a part of it.
So I guess on that note too, kind of circling back, so part one of this question is, what would you say is the biggest challenge of Lake Superior? And then part two of the question, are there opportunities for alumni to do anything about it?
Yeah, great questions. Well, what is the biggest challenge is somewhat up to the sort of in the eyes of the beholder. I personally feel this climate change piece is the most concerning thing because it touches on everything. Again, not my field, but I certainly, as a consumer of information, I'm paying a lot of attention to PFAS. Frankly, I'm pretty spooked about some of the things that I'm reading as an interested scientist and member of the public about PFAS. That's something I'm going to want to pay attention to as time goes on. There's still some legacy contaminants that are mercury and some other things that are a concern. We've been pretty safe from invasive species, not entirely safe from them, but pretty safe from them for a couple of reasons. One is temperature. The lake still, in spite of the fact it's warming, it's pretty cold. It's soft water, which keeps the invasive mussel populations greatly suppressed. That's important. You know, but it's a wild card. Invasive species, when they get the right chance, when the right species gets the right chance, ecosystems flip in a very, very rapid time scale. So I don't have a specific species that's of deep concern. Invasive carp might be something that, you know, could create some significant problems, but any kind of yet undescribed or unknown invasive species might just, you know, conversation could really pivot if something like that happens. So those are the kind of things that keep me up at night.
Well, how about we end on a hopeful note? Are there things that you're hopeful for and excited for, not only with the work with LLO, but just kind of holistically with the Great Lakes?
I guess, you know, geeky science answer to your question, but the amount of science, there's not enough science on the Great Lakes. We're very far from being able to answer many important questions with any degree of confidence. We need more, but things are so much better today than they were when I started in this field 20 years ago. You know, we have the blue heron, we have more scientists, there's just more work going on in the Great Lakes. Science is ramping up, it needs to ramp up faster, and I'm part of several initiatives, one through the International Joint Commission that's trying to give these lakes the attention they deserve. But things are better than they used to be. We know more than we used to. You know, sea level rise is going to be a significant challenge to millions of people in the future. Drought conditions are going to be a significant challenge to millions of people. The Great Lakes, Lake Superior specifically, I think are going to be just increasingly valuable to us in the future, to our kids' kids.
Well, with that, I would just like to thank you so much, Bob, for taking the time to share the insights with us. It's fascinating and also fairly time sensitive with this changing climate. And so we just appreciate you taking the time to visit with us. And I know that you had mentioned there's a potential newsletter coming out. So our office, Alumni Relations, once those details come together, we will also be sharing that information as well. And additionally, if you are not an alum or this is your first time joining us for Behind the Scenes, our office hosts about 1 to 2 of these sessions every month. So feel free to either email us or keep an eye on your email if you're receiving communication for future events. So with that, thanks so much, Bob, and I hope you all have a wonderful day. Bye now.
Thank you, everyone.